All right, guys. So remember at the beginning of the probability unit, had us take a fake test, right?
Oh, I read that.
Everybody failed.
I got a 2.
You got a 2? That's great. That's really good. Good job. So, in to check your understanding, we have the same thing. So we had 10 item test. Answers had choices A through E. And then if you have a random key, right, just same thing we did, use a random number generator to produce a key. If we have the random variable x be the number correct. As promised, now we have the tools to actually calculate the probability of getting a certain number correct, right? First of all, though, before we do any work on this, we have to verify that it's binomial, right? So we'll verify our base. So, is each one binary? Is it binary?
Yes, sir.
So yes or no? Yeah, you either get it right or wrong, right? So yes, because it's either right or wrong. All right, and is it each observation independent?
Yes.
Exactly. Getting one right doesn't change the probability of getting the next one right. And then our n so so that stands for number, right? Are there a fixed number of trials? Definitely, right? There are 10 trials. And then our last one, S stands for success.
S stands for success.
It's so weird because it's S is success, and really, I wish it was BIM. because really we're talking about probability, right? So success refers to does each event have the same probability? Right, and it's true because they all have a probability. Each question being answered has a probability of 1/5 being correct, right? Fantastic. So now that we've checked our bins, we can go ahead and do some calculations. So they're suggesting 3, but so they suggest that you check for x equals 3, but I mean, and why not? Let's do it. All right. So NK times our probability to the kth power times 1 minus our probability to the n minus k. Boom shakalaka. Alright. Which, if we calculate, turns out to be 0.2013. So we could say there is about a 20% chance of getting three correct. Fantastic. Hey. But that's not the cool thing to find out. It would be really cool to find out if you could actually pass it. What are the probabilities of taking a 10-question multiple choice test where each question has 5 different selections? What are the chances of getting it? What are the chances of passing? I think I said it twice. 60 or higher. So 70 or higher would be really crazy. And I think we should calculate a bunch of these things. I think that working on these things really gives you a feel for how to do these problems, right? And let's calculate the probability that you fail, the probability that you pass, and then make the probability of getting an A as well. Alright, so let's say what is the probability of passing? What does passing mean? That means
not failing.
It's the passing is the complement of passing is failing. Yeah. That's really bad stuff. So we're saying 60% or better, right? Which is going to be the probability that our random variable x is greater than or equal to 6, right? So that's going to be equal to the probability of x equals 6 plus the probability of x equals 7 plus all the way up to the probability of x equals 10, right? That's really what's going on. Oh, cool. Thank you so much. Awesome. Can't believe I left that in my house. Huh? So, to answer this question correctly on the AP exam, you have two options, okay? You can actually put in the calculation, so you can actually, but this is a lot, right? 6, 7, I mean, I guess I just skipped 8 and 9, right? And that's going to be a lot of calculations to show, because you're going to do, you have to do this one, you have to do this for each of them, right? It's going to be a lot of calculating. So what you can do instead of that is actually enter the command that you're putting in your calculator, right? So you're going to say, hey, I'm using binom CDF, my bad, not PDF. CDF. Right, and real quick, we were getting into the calculator stuff at the very end of class, so I don't think that last time, at the end of the lesson last time, so I don't think that we got super specific about when to use each, right? So you're going to use binom CDF if you're calculating a bunch of them, right? It's going to give you the cumulative distribution function. And this one, for something like this, where you just have the equal sign, you're going to use PDF, right? So this is just probability, binomial probability distribution function, and CDF is cumulative probability distribution function. So it's going to do a cumulative, right? It's going to do all of them combined into one. And also be careful that when you do this, and it's N P K Alright, be careful when you enter this, in your calculator, what it's actually doing is the probability that x is less than or equal to 6, right? Okay? So it's going to spit out a number, and we're going to have to actually take the complement. Alright? We're going to have to actually subtract from 1. Because that's what would give us the probability that it's greater than or equal to 6, right? Alright. Okay, so let's get out our handy dandy calculator. Alright. So in order to get to that, we're going to go a second bars to get to distribution. And we've got to go all the way down to binom CDF. Boom. And remember, if you have an 83, it's when you hit enter on that, it's going to just give you binom CDF and then a parenthesis, right? And you have to put whatever n is, comma, whatever p is, comma, whatever k is, right? In this case, it asks us. So we're doing 10 trials. The probability for each trial is 1/5. And our x value that we're looking at is 6. So that is 0.999, right? But remember, this is spitting out the probability that you get 6 or more wrong, right? This is actually the probability of getting 6 or more wrong. So what we've done, so we've inadvertently calculated the probability that you fail, right? Which should be fairly high, right? So this spits out 0.9991, but our answer we're looking for is actually the complement of that. We're looking, so, and we can go to our calculator and just go 1 minus our last, oh. Why did you have that? And we'll hit enter. Okay. And I'm sorry, I should have written. That was a bad kid. I didn't write my approximate symbol. I need to write my approximate symbol here. And that was. Okay. Oh, yes. So yeah, this should be right.
Oh no.
You're right. Off my game. So we need to recalculate. So we'll recalculate this distribution. So guys, I made a mistake. Just so you know. It should be 5. Mark it in your notes.
Oh yeah, look at that.
Alright, so we'll go with point, well, we need to subtract, right? Well, we'll mark down what that is. We'll go with 0.9936. So this is equal to 1 minus 0.6. Alright? And I'll just let my calculator do that for me. So 0.006. All right. So to put that into context, you have about a 6 in 1,000 chance, right?
Just kidding.
So 6 in 1,000 chance.
Just like you. Guys, my little bird will live with my mom first.
Alright, so do you guys have your results? Do you remember? Is it somewhere in your notes somewhere? How you did on your test? Did you beat the odds?
I beat the odds. I forget.
You did not beat the odds? Were you one of those 6 in 1,000? Or did you? Huh? A couple of people got 6. They both.
Yeah, we beat the odds.
Yeah, for sure.
That's
That's pretty unusual. Did everybody have the same seating in their calculator? Well, okay. Feel like looking at the probability distribution of this. That's kind of a big one. Alright, gosh, that's a lot of them. Let's pretend we're looking at a 5-question test. Let's look at a 4-question test. Sorry. Alright? Because 10 questions is going to be a lot. So let's do the same thing again. So in this case, n is equal to 4, and p is equal to 1/5 still. So we looked at a 4-question test. Let's look at the distribution of this. So I have to calculate each of these things. I have to calculate the probability of 0. But I can go shorthand on this, and I can actually go to my distribution, and I can do PDF instead of doing all of those calculations. Alright. We'll go 0.41. Alright, what's the probability of 1? We can spit these out pretty quickly, because I can just copy my last entry and change my value for k to 1. Right. 0.01. We'll round to the 10th place, just this first phase. Let's do 3.
Oh, nice hit.
Go down to 0, 0.
For sale?
Okay. All right, cool. So that's our probability distribution. We can draw a histogram of this thing, which is a good skill to be able to do.
For the record, that's 1.00.
That is because I rounded a bunch. Yeah. It's because of all the rounding that I did. Because I rounded space, it would be more correct if I would have rounded to thousands. Yeah, so you said 1.001. So I didn't round this one to the thousands because it would be 0. And that's where your 001 is coming from. So technically, if I'm rounding them all to the hundreds place, right? I should have rounded this one and would have made it correct. It would come out to, right? If I would have rounded each of these to the thousandths place, it would then add up to 1. So if I round differently, it's going to mess it up. But unfortunately, I don't want to write this as a 0 probability. So cool. Something like that, right? That's what our probability distribution looks like. So let's calculate the mean of our random variable x.
And I should be that one.
I'm going to run out of room. So I'm not going to change anything that I wrote. I'm just going to write it over here. 3 times 0.03. Alright, let's calculate that. I'm going to use my handheld. Oh, thank you. Do you round? No, it was exactly. Alright. Okay, fantastic. It turns out that if we have a binomial random variable, we get something cool to happen. It should be the case that just for a binomial random variable, we should be able to multiply n times p. Sorry. They're supposed to be equivalent. No, we should actually get, it should be equal to n times p. We'll see what happens. That worked. Alright, we'll pick this up. Alright, so that was miscalculated. This should be 0.804. And then we'll be able to actually talk about how the formula goes.